If I'm determining the equation of the graph based on a graph that I see and the key points that are given, in this case it tells me that it shows the x and y intercepts on the graph. Well, the values of m and n are going to be these two x-intercepts. The values are going to be m is equal to 3 and n is equal to 6. If I need to determine a, I can use the y-intercept, which, even though it says 36, occurs at the coordinate of 0 and 36. These are prospective x and y values. Any point that the graph goes through is a possible value for x and y. So I can substitute my m, my n, my x, and my y into my original equation. And I'm going to say that y is 36 is equal to a, which is what I'm solving, bracket, x is 0, and m is 3. X is still 0, and m is 6. Which means that 36 is going to equal, well, 0 minus 3 is just negative 3, 0 minus 6 is negative 6. When I multiply them together, I'm going to get 18. If 36 is equal to 18a, when I divide both sides by 18, a is going to equal positive 2. If I'm writing the equation in my factored form, I'm going to substitute in the values of a, m, and n, and then just leave x and y as x and y. So I can state that, based on what I found, y is equal to 2, bracket, x minus 3, and x minus 6. If I'm determining the coordinates of the vertex, well, the p-value, the h-value at the vertex is going to be the same as the axis of symmetry, which means that if I said that the axis of symmetry was equal to x is equal to 3 plus 6 divided by 2, or 9 over 2, then I can substitute that in for x and solve for what the y value or the k value would be. I'm going to say that y is equal to 2, bracket, 9 over 2 minus 3, and then x is still 9 over 2 minus 6. And that's going to give me the value of negative 9 over 2. Well, now I know that my vertex occurs at the point of 9 over 2 and negative 9 over 2. If you didn't leave them in fractions, but didn't have to round, and you said that it was at 4.5 and negative 4.5, that's also acceptable. Just make sure you're not rounding. If I am using this to write the equation in standard form, y is equal to, a is still the same, 2, bracket, x minus h, or minus 9 over 2, squared, minus 9 over 2. If I'm determining the coordinates of the vertex of a graph if it passes through points of negative 8 and 0, 2 and 0, and 0 and 48. Well, this is my M, this is my N, and this is a possible X and Y. The two X-intercepts, or when Y is equal to 0, are my M and N, and the other one can be X and Y. And I'm going to do the same process. So if I said that M is equal to -8, N is equal to 2, X is equal to 0, and Y is equal to 48, then I'm going to state that 48, which is my Y, is equal to A, which I'm solving for, bracket, X is 0, plus 8, and X is 0, minus 2 for my M and my N. Or 48 is going to be equal to 8 times -2, -16a. When I divide both sides by -16, then -3 is equal to a. If I know that -3 is equal to a, I can solve for my h because it's going to be the axis symmetry. H is going to be when I take M plus N divided by 2, or -8 plus 2 divided by 2. And in this case, it's going to give me -3. I can solve for my k, because my k is going to be my y value at the vertex. And I'm going to say that y is equal to -3 is where a goes, bracket. My h value is -3 plus 8, and -3 minus 2. I'm substituting the h value or the x value that I know for what this is going to be, and I get y is equal to 75. This is also my k value. The vertex occurs at the point of -3 and 75.